Hello, I'm Graham Horton and welcome to this video. A change from either a product review or a tutorial on Panasonic or Canon cameras. I'm looking at modifying one of these outdoor balloon lights which have been very popular this year in a lot of the stores. They are solar powered and in the dark the solar power turns on the electronics of the device and you get this flicker flame effect. Very nice when it goes dark, beautiful little lights. The trouble is, in winter time, these don't get enough sunshine to run for more than about 20 minutes. So this time of year is not very effective. Got two different types here. The smaller type, which I've already converted to run on a AAA battery pack. That's what we're going to do in today's video. I'm going to show you how easy it is to convert one of these solar units into a battery pack. Now the actual module that these things use, I'll just show you here on the desktop. It's a solar powered unit. Inside is a voltage converter, and during the daytime sunlight charges up an internal nickel cadmium battery, and then when the solar cell is blocked off it allows the electronics to switch in this little circuitry on the LED panel here, and that simulates a flame effect. Normally it's held this way down, so it's held vertically, and if we see that, you can see the effect of the flame is sort of continuous at the bottom and then it flickers up towards the top. So it looks very effective. You can mount these the other way up, so if you mount them that way up, invert this the other way around, then you can have a flame which starts from the bottom to the top if you want to make some sort of an ornament which looks like a candle. To convert the solar power into a battery power unit, I'm going to be using a LED candle. Now this one is sold in the UK at the B&M retail stores or B&M stores. This one is the cheapest in the range and it's £2.50. The only reason I bought this was not for the flicker flame, which is a very poor flicker flame. They're not very nice. If you get one of the flicker bright ones, they are much better, but the reason I bought this was just for the battery box. You've got a AAA by 3-cell battery which gives you 4.5 volts, which is ideal to power this unit, which was normally around about 5 volts. So the only reason I say it was to allow me to use the battery box. Now the second part is this unit, and it's from Primark here in the UK, and it's a 50 LED set, these micro light bulbs, and again it contains a battery box, but this one's too large to use on the device. But the interesting feature that I want here is behind this panel, which is a timer board which allows 8 hours continuous and 16 hours off. So that is the reason for this. We just want the little chip that's in there to give us a timer. To complete this little project you'll need a soldering iron and you'll need a hot glue gun just to glue some of the components together, some solder, etc., to allow you to solder the wires together. We're going to start by removing the battery box from one of these units, and it's easier if you take the cover off the bottom of this device, and then if you just use a screwdriver into the base of the unit to start prying it up from the wax. They are only just so hot glued in, they'll come out very easily, so you can remove the battery box and then just snip the wires, so you end up with the battery box with its two wires, which are the positive and negative from the batteries, which are going to be used to power our unit. So that is the battery box. Now that battery box is an exact fit for the hole in the top of these solar lights. So these are the larger ones, the ones that take the larger cell. So this fits in there very snugly, and it becomes our indoor powered LED light. So let's put that down on one side. We're now going to remove the timer unit from the Primark switch unit. So again, it's just a simple press, puts it on for 8 hours, continuous press puts it on for 24 hours, and another press turns it off completely. So we're just going to remove the batteries from this unit, and I'm going to remove the cover which is over the integrated circuit that we want to take out. So I'm just going to prise this board off here. And that's the little circuit in there that I want to utilize for my device. So we're just going to remove that board. Again, it's only sort of hot glued in. Just take out the battery terminal there. And again, you've got the two leads here which go out to the module, and again they're just hot glued in, so it's easy enough to just break that hot glue to allow you to get the wiring out. If you like, you could desolder these and put new wires on, and that's what I'm going to do with this project. I'm going to take off the L1 and L2 light to allow me to solder new wires on. So just with a soldering iron, just going to unsolder those two leads and also the one from the battery. On that circuit board you'll find the negative terminal which is connected to the circuit board, so again I'm just going to desolder that. So that is all we needed out of that unit. You can put that on one side. We've got our little printed circuit board which has got the onboard timer and the crystal there, 32767 kilohertz, which is used to drive this little microprocessor which will turn on the timer for 8 hours. What normally happens with these units is, even though I normally apply some tape over the switch area, water does ingress into these things, and after a short period of time you can see that it destroys the circuit board inside the unit. Fortunately, the units are normally okay, so the unit that we're going to use is still here intact, but the inside might very well be destroyed. So I'm going to take the cover off this unit so we can have a look. It's just 3 screws hold the electronics into the device. So, and you can see inside this one it's full of condensation or water. The whole circuit board has started to corrode, and in fact the positive lead to the module is actually now separated from the printed circuit board. So now you will find that they're supposed to be IP65 weather sealed, but in fact they are not. There's no gaskets on here to stop water ingress. Now I used to think that it was from the switch, so I taped that over so there's no water can get through the switch, because these are mounted vertically and you end up with a pool of water within the switch housing, and eventually that gets through. But I take that over so no water can get in there. It can't be through the solar cell because that's sealed, and it is a very effective seal. So it can only be condensation or water that runs down and seeps back up from that side seal. So not very well protected against rain or condensation. So I'm just going to snip that off and put this on one side. What I want to do is actually remove this module, and again it's only hot glued into the bottom of this device, so it's very easy to remove. You just need to slightly pry it. Just going to slacken the hot melt glue around that hole to make it easier to take out, and then I'm just going to try and pull this out. So I'm going to wiggle backwards and forwards, and we managed to remove it. You can leave that hot glue on the bottom, or to clean it up it will normally just peel off the circuit board and leave you with a nice clean circuit board. We are going to replace this cable to make it easier. There is a little bit of fretting on the top of this board here where water's managed to ingress it, but I don't think that's going to be an issue. In fact, I'll just quickly test this on another battery box. So I'm just going to strip a bit of wire off each of the leads here. I've just attached to one of those battery boxes to the device, and you can see that it's still operational, so we're good to go with this particular module. So I'll start by just desoldering these wires off the circuit board. The positive is the right hand side and the negative is the left hand side, but they are marked on these modules. So with the battery box, we're going to mount the timer module onto the side using hot glue, and then we can wire the module to the LED module itself. We'll start by connecting the battery box to the module, and we have marked on here plus and minus. So the plus switch goes through the switch. I'm going to just cut this wire to length to strip some of the insulation, and then with the negative lead again just cut some of the length off, strip off the insulation. We'll just tin these to make them easier to solder. So again, with a soldering iron and your solder, we can tin the leads. We'll connect the positive to the positive, and I'm just going to trim a little bit off the end of there so we haven't got a grate. I'm going to solder the plus, and we'll solder the minus, and now we're going to connect two leads, the plus and the minus, from the timer module back up to the LED module. Well, I'm not sure what happened to the overhead camera. I'm not sure whether they captured all of that, but all I've done is connect the negative from this battery box to the negative on the timer, which is the one opposite the switch, and the positive, which goes through the switch on the battery box, to the positive connection on the printed circuit board. And I've connected the LED module. Just wire that from the L plus to the plus on the module, and the L minus to the minus on the module. I've got 3 AAA batteries, so I can put that into the box here and just check that we've got the wiring correct and everything ready before we start to glue it together. And with the unit in the on position, we can then use the little switch here. One press should put us into the timer mode. There we are, and the second press will put us into the continuous mode, so that's fine. The third press will turn the module off. We're going to mount this so that the main module is in the center of the device. I'm in a little trouble with the Yola box today. It's not performing the way it should. Things seem to be happening that are not under my control. So we're going to mount the LED module on the battery box with some hot glue, mounted in the middle, and it will be held vertically like so. And then we're going to mount the timer unit on the side of the box, so we can see that here on the desktop. So the timer unit will be hot glued to the side, and the module will be hot glued to the center. So a little hot glue there, and we're just going to put the timer module onto the device, and then a little bit of hot glue in the center there to install the LED module. So again, just positioning that in the center, just holding it for a couple of seconds while the glue sets, holding that in position while it sets. It's probably not quite enough glue on the base of there. Just going to put a little bit more hot glue around the base of the LED module. So now we have the timer module and the LED module mounted to the base. You can put the battery box cover back on, and now this will fit neatly inside the existing globe, like so, and we have our battery powered flicker flame effect balloon light. I've had 3 of these running in the conservatory as sort of Christmas decorations, and they've been running 5 days now on the AAA battery, so they will run a considerable period of time with that timer set to the 8 hours, not the continuous on. To turn it off, obviously just turn the switch on top of the battery box off. But if you do turn it off, these are not self-resetting timer modules, so when you turn it back on again, it won't turn on. You just need to remove the module from the balloon, like so, and just press your button once to put it into the timer mode. Some of the modules are self-resetting, it depends on the type of module you get, but the cheapest one I could find was those Primark lamps, which give me the 8-hour timer facility at the cheapest option I could find. So there we are, that's how to convert your solar powered balloon light to battery powered. Obviously you can't use this outdoors, it is not sealed for weatherproof outdoors. You could go to the expense of making a cover to fit on top of this to totally waterproof it, but again you're still going to suffer condensation, so that would be an issue. But I just designed these for Christmas decorations, as you can see in the video at the moment. Well, diversion it was from my usual reviews and photographic tutorials. Hope you enjoyed that. In my next video I'm going to show you how I converted my outdoor wall clock, which again is battery powered, a single AA battery, to be solar powered, so I don't have the problem of having to remember to change the battery as it starts to run down, as the clock generally runs a lot slower as the battery voltage drops. So I converted it to solar power and it's been running all year without any issue. So I'll show you how to do that in my next video. So until then, thanks very much for watching. Please do take care, and I hope to see you all very, very soon. Goodbye for now.